Our belief when we introduced the Signata platform and the semi-automated Signata CT5 was that flexibility and the ability to integrate between unit operations was really key for advancing cell therapy manufacturing. The idea that you can use a system to coordinate between very well working, robust processes was something that seemed missing. The ability to connect in a closed manner and move fluids from unit operation A to B to C was a struggle. Our belief is that with the Signata platform, you'll be able to semi-automate those tasks, bring along electronic batch records, and close them out, taking some of the most basic functions in cell manufacturing and bringing it closer to a true GMP manufacturing protocol. Today, we're going to show you how that actually works with the Signata CT5, connecting this system, our system, with outputs that are both our proprietary vials or bags, connecting it to bioreactors or other growth chambers, and really demonstrate the power behind the system. We initially designed the CT5 to make sure that we had flexibility in fill and formulation of the final container. So options such as vials, our proprietary cell seal vials, or cryo bags, whatever the user wanted to fill into it, whatever volumes. That was the key starting point from the specifications. But with the intent of really developing and delivering on a flexible fluid management system where you could do multiple different operations, we came up with a unique design element that is really kind of special. So all of the fluid control valves, rather than being pinch valves, are 3-directional T valves driven by a driver that's on the system. All the pumps are reversible. So with multi-directional fluid flow, multi-directional fluid paths, it really opens up the possibilities for what you can pull into and push fluid out of, including air if you wanted to chase the lines to empty them out so that you didn't have any holdup volume in the tubing. The key to that, really making that real, was the transfer set design. So the transfer set itself here has multiple tubes that are initially identified as source lines, obviously the peristaltic pump tubing, and then 2 output lines. But what really is unique is that there's communication here at the bottom between the 2 peristaltic pump lines, communication here with 2 sets of 2 at the top. The resulting flexibility within the transfer set means that you can simply use this as a peristaltic pump to draw from one bag to pump it out into any other bag that you want or any other output, or draw things in from either side of this and put it into another bag. If you wanted, for example, to make a formulated media bag, you can connect this to 3 source inputs if you want. In theory, you can actually connect it to up to 5 different source lines here, just with the transfer set alone, to fill a media bag. So you can do relatively complex media formulation in a closed system using this simple transfer set. So operating the Signata CT5 requires basically 2 different types of output consumables. One, the actual container output consumable set, which is vials or bags or whatever you want to pump fluid into. And the second one is the transfer set. You really only always need to use the transfer set. The output consumable with the vials, if you're doing something only utilizing the pumps and the control valves up at the top, this would be the only one that you need to use. In fact, if all you're doing is transferring from one source bag to another and you have an appropriate line of silicone tubing to put into the peristaltic pump, you could in theory use it that way as well. So the first step in getting ready to use the CT5 is installation of the transfer set, which is pretty simple. The lines here, there are several lines, but it goes on very easy. That lines up simple into the stopcock drivers here. Thread in the peristaltic pump tubing. Mount the retention screw just to hold it in place. Add the second tube. And that's pretty much it. These tubes can be set out of the way. These tubes set out of the way as well. Then, to mount the output consumable set, it's essentially the same process. Press the drivers in, add the retention screw, set the lines into the optical detectors, place the last silicone tube, and that's it. So we talked a lot about integration between other existing unit operations and systems. So what we wanted to do next was demonstrate how you can actually use some of these existing products out there and technologies that you may already have in your system and use the Signata platform to manipulate them. So for example, a multi-layer cell culture flask or a T-cell incubation growth chamber, and even a cell filter process. And so we'll demonstrate how you can connect the system and how the fluid management processes for each of those works. So the first application I want to show beyond the fill and finish, the final fill capability of the system, is filling bioreactors or growth chambers. In this case, we'll do a three-dimensional multi-stack growth chamber here. In this case, it's the Corning cell stack. These have these nice tubes for filling in a closed manner. In this case, we're just using the lure connections that our system comes with and that this adapter comes with out of the box. But if you had a weldable tip that you want to place on there, you could actually do this on the bench top instead of in a BSC. So as I mentioned, the flexibility in the transfer set, in this case, we have a media source bag hooked up one line into the third position of the device. We'll run through the higher volume pump and set the fluid valves to control to make sure, and this is a manual process right now, you set the fluid valves to control which direction you want to go. We're going to output through this line. Set the pump speed, we'll do pump speed of 500 mils per minute and fill, we're just going to do a low amount of volume on this one so it doesn't take too long, 150 milliliters, and set it to go. So on the manual screen, again, you'd come over here, set your pumps up with the right volumes and the speed that you want, hit forward, direction, and start. So obviously, you normally want to put a little bit more media in there than this, but if you had, for example, some additives you wanted to put in a closed manner, you could hook up additional media sources that you could add into there. You could even inoculate cells directly in without changing any of the connections and have it already all set up. And obviously, the second step with this system, put it down, make sure it's all on every layer, and you're done. So the next operation we're going to want to demonstrate here is manipulating fluids and using the G-Rex growth chamber. In this case, we have this set up where we've already loaded some media in it. Now we're going to switch over and load growth supplement, in this case our HPL. We're going to load a little bit of volume into that. And then in the second phase, we'll manipulate the valves, change the valves over, and then actually use positive pressure to do some evacuation of the chamber. Obviously, in normal circumstances, you wouldn't leave it connected and you wouldn't necessarily have to have everything all connected at the same time. But we just wanted to show you the versatility of the different kinds of things you can do simply by switching around some of the pumps and the valves. So it's already set to go. We're going to hit go and load this with a little bit of Enliven. Pretty simple and straightforward. So then the next phase, we want to evacuate this line so that this no longer has any of the media in it, because what we're going to do after that is use the air pressure through the filter, and I want no fluid in here. So to do that, we're going to change this valve that I added onto the end of it here, running through a filter. We're going to hit reverse on the pump this time and evacuate that line. So up it goes, there it is, it's gone. Now I can go up here and clip this supply line, and you're ready to go to the next phase. So at this point, I'm going to change a couple of the valves to get them set to now draw air in through a sterile filter here on the system, and it's going to go back through the sterile filter on this system as well. So we'll make sure we've got the valves set the way I want them. And we're going to pressurize the system so that we can fill this bag up here with the output. It's closed. This one's open. couple of valve changes here. Should be ready to go. Going to use the same pump. I've got both of them going through there on the line. In this case, we'll just use the same flow rate for the systems as well. And here we go. And you can see the volume flowing up into the extract bag. So, closed system integration, semi-automated process. It's just a really nice way to kind of integrate all of your different unit operations, anything that you need semi-automated fluid transfer with. This has a real versatile flexibility on the system. So in this example, we're going to demonstrate how you can use the system to do a closed transfer of a couple of different solutions into a third bag. In this case, for example, if you wanted to make media, complete media, you've got your culture supplement here, maybe some other additives that you want to put into it in your basal media here. So in this case, all three of these are connected. To do this, we're going to draw using the high flow pump from these two supplements. So that will be position number 3 and 4. Use the high volume pump. And then we're going to transfer it directly over here into the media bag. So in this case, you just open this pump here to allow fluid to flow through there without running this pump. Have it set up, ready to go. So in the first case here, I'm going to draw, what have I got, 50 mils from the Enliven supplement. And you can see it transferring. Stop, then we'll go back to the fluid control valves. And this is the valve, we're both connected to here, so we need to change that one to the way we wanted to go it. That's TC2. We'll do 1 turn counterclockwise. Go back to the pumps. Again, it's the same pump here, so we'll use the same speed, in this case 300 mils per minute. We'll transfer 20 mils in this case. Correction factor at 1, okay, it's all good. So we can make sure, you always want to make sure you hit the forward speed. That'll light up, hit start. Well, that's ready to go. Now, of course, one of the questions about this is what kind of line residuals might you have in the volumes here. The simplest way to do that is you actually could use a third line here with an air filter, sterile filter, and you can actually back flush all of these back into your original bags, and that way you have it if you don't use all of it. If you use all of it, you just chase it through all the way with air. One of the features of the CT5 is the ability to remove air if you're filling bags. As you're probably aware, sometimes when you fill a bag partially, you're going to end up with a little bit of air in there, which is not particularly good for freezing. So we added a pump on this system that with bags, you can actually remove air semi-automatically using the pump, or if for some reason you wanted to in fact add some volume of air, maybe you want to overlay your product with nitrogen for stability, you could do that as well. So in a bag filling process, normally this would be an option at the end and you can do it through the protocol, but I've just set it up here through the service screen to get access to the pump and the flow control valves just for demonstration purposes. So it's all set up, ready to go. So you just hit start. As you can see the volume going up, and then you can slow it down to get the last little bit. And so I slowed it down early. It's probably going to take a little while. So you could speed it back up, slow it down, and stop. So in this setup, we have an interesting cell filter here that works by gravity filtration. What we're going to do is use the CT5 to load the source bag here. In this case, we've got a bag of 10 micron beads. We're going to pump that through into the top part of the filter. We'll open up the filter, let it go, move a couple of control valves, and then backwash this filter into a collection bag, in this case a cryo bag. So we'll use whatever your formulation would be here, final formulation, to kind of wash it off the filter. So again, we'll start by loading the source bag. Okay, so after the filter is done draining through, the cells, or the beads in this case, are collected on the filter. Now we're going to backwash with our formulation media. So we're going to go through this line here, pump it back, and into the cryo bag. So we make sure that the clamps we don't want are closed now. The ones we want are open. Open, 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 ready to go, and then hit start. And then you can see the beads transferred into there. So I was able to take the solution from the starting bag, run it through a filter, put it into a final container, all within a closed process. So the last operation we're going to show today here is the actual fill process. So when people initially start talking about the CT5, they're envisioning it simply as a fill finish system. In this case, we've got our off-the-shelf bag consumables loaded up here. I have the infamous blue scientific fluid that I'm going to fill into these bags. I wrote a protocol here where each of these bags has a different volume on it, anywhere between 50 and 10 milliliters, and these are the 250 ml bag sizes. And so on the system, you pull up the protocol, load it, go make sure all of the pieces are connected, and then hit start. Once you hit start, it's going to prime the system and then start the fill. So I've got this on a partial prime, so it's going to be quite fast before it starts the fill process. I'll just demonstrate how that goes. So there's a prime. It's all the way over here. The system, as it loads, will ask you if it's complete. Yes, it's complete. Then it's going to go back and start filling the bags one at a time. So on this protocol, I have the fill speed set at 300 mils per minute. This goes up to over 500 mils per minute. So the real time involved in filling bags in this case is just the simple steps in between. The fill speed is really pretty quick. So there you can see in this case, this volume was pretty close. I believe this one, when I set the protocol up, was probably about a 5 mil difference between these two bags. So at this point, it's just going to continue to go on down the line, fill the bags as you asked to do it. If you had multiple outputs that you wanted to fill, say you're going to do 10, 15, or 20 bags, once it finished those 5, it would prime back to a place where you can reconnect the line either by lure lock or sterile weld, and you continue on with the protocol. So I hope these videos were helpful and demonstrate really the versatility of the system. It's really intended to be a versatile fluid handling system that sort of semi-automates or automates very basic, simple self-manufacturing processes that just haven't been involved up to this point. So thanks for your time, and have a good day. I think there are two pieces to that question. Think about them a little bit separately. I think the first piece is that controlled electronic records and sort of closed process filling systems for bags is a new thing to the industry. There are a couple of really good options that have recently come out. We believe that we have something that meets that need as well. One of the key differences for us, though, is that we're not locked into one type of solution here. There's a lot of flexibility in terms of you can fill vials, you can fill bags, you can fill it with different kinds of bags, multiple volumes. So really the robust flexibility is one of the key attributes. The second piece points back to that inherent flexibility in the versatility of the system overall. Really, yes, we came out with our initial discussion around fill and finish, but in reality, this is a closed fluid handling system, and keep that in mind, that the flexibility there is really quite unique. I think there are a couple of different directions that automation, manufacturing, and semi-automated processes in cell therapy is going to go. On the one hand, you have most likely purpose-built, fully automated manufacturing facilities that are going to get built. And this kind of individual piece of equipment is probably not going to fit into that as we move in that direction. But what we intend to add to this piece of equipment is modularity and capability to expand on it. So right now we've already expanded from fill and finish into a lot of different basic cell processing operations. We've got more things on the way, additional units that can be connected to it, and additional processes that we'll be launching and bringing out. So as we kind of move forward with this base system, really think about it as something that can lead you to be able to process in a semi-automated way anything that needs fluid movement as the basic underlying principle.